Now that our toolpaths have been calculated, we can see the results of applying the toolpaths from the iron onto the video game control. We're first going to look at our 12 mil roughing program. By double clicking on either the calculated side or the optimized side, it will display the toolpath on the screen. To get rid of it, simply click the Clear CL checkmark button here. We can now look at the Z-level remachine, 6 mil, remove more of the stock. We can see our stock model at the current state. As well, we can see the animation of the material being removed. As we move our way down the list, double-clicking on programs, we can see the rest of the programs we have in our list. If we hold Control as we click these programs, we can see multiple programs at the same time overlaid over top of each other on the screen. If you notice these red dots that are appearing in these holes, what those are is CAMTOOL's way of telling you that the toolpath did not go into those holes, even though the tool would technically fit. There are parameters inside of the toolpath that are keeping it out of those holes. This is the CAMTOOL's way of letting you know that that was not machined. As we look at the toolpaths, we realize that there are areas that were not finished by the 6 millimeter ball. So we will need to add some programs to this in order to finish this part completely. We are also noticing that this part is not as deep as our iron. Because of that, we want to keep our tools as short as possible. So what we're going to do is select these three 6 millimeter programs and change our protruding length to 20 millimeters. We're also going to go and change our 10 millimeter cutters to 25 millimeters. We always want to keep our tools as short as possible when machining. We're now going to re-optimize the programs to collision check them with our new protruding lengths to ensure they are not colliding. You'll notice it calculates much faster than a full recalculation, as it only has to do the optimization side instead of a full recalculation. Now that our toolpaths have re-optimized, we can check our optimization condition to see that our tool is much shorter than it was for the iron. This is going to allow us to become much more aggressive when machining. The next thing we need to deal with is adding more programs to deal with the smaller radiuses. As you can see, some of these radiuses are much smaller than what our 6 mil cutter will finish. We can either use our radius shading again. This is going to show us the size of the radiuses we still need to finish. We have 4 in here, so anything that is shaded red is smaller than a 4 millimeter radius. To get a more exact measurement, we can use surface shape, analyze shape, fillet surface radius info. We can then click on radiuses, and the size of the radius will appear along the radius. Looking at this radius, we need to finish this with a 0.55 millimeter radius. In this case, we will use a 1 millimeter ball. So we will need to change to add programs from a 6 millimeter down to a 1 millimeter ball to finish this part completely.